Hello everyone, my name is Harry Timothy. I am Android engineer from Dana, and today I'm going to present quite a rare topic, reactive app orchestration with StateFlow. As we know in today's practice, building a reactive app is not a new thing anymore. There are currently many ways to achieve it, so the key point of this topic is whether or not we understand StateFlow. Uh, whether or not we can adopt it to our app architecture. And I'll begin with a quick summary of what did we have in Coroutines before StateFlow ever created. So Coroutines firstly came with coroutine scope and dispatchers, and shortly after, they introduced both buffered and non-buffered channels. I believe most of us have learned about coroutines as structured concurrency has been a trend in today's practice. Even if you haven't, it is not difficult to learn how to work with suspend functions, as there are plenty of online resources today. And then we have Flow to asynchronously handle stream of data in sequence. It is a cold stream with a very convenient builder which has many kinds of operators. As Flow is the base foundation of StateFlow, I will give a quick review to ensure everyone can follow this topic. So in this piece of code, we can see an example of data emission and collection using Flow Builder. We try to emit 3 values of string, and then and the printed output is exactly in the same order it was emitted. Another way is to create another way to create a flow is by using asFlow function. This will turn a collection or a sequence into a flow and emit each item it contains. Uh, However, let's consider this case. Let's say we have an activity which starts with rendering the initial state. Then let's say clicking a button triggers loading state. Then the result can be either success or error state. So there are 4 states in total. The question is, how do we manage these states using what we currently have in Coroutines? Well, in today's practice, there are several solutions to this problem. For example, we can use Rx Observables, we can use LiveData. But what about coroutines? What solution can coroutines give us to manage these states? One of the most recommended solution is by using conflated broadcast channel. So conflated broadcast channel broadcast the latest sent value to all open subscriptions, and as the name suggests, values are conflated, means that every subscriber will only receive the most recent value. Uh, so to make it short, it has a constructor which immediately sends the assigned value when it is created, and uh, and then we can access its open subscription by using open subscription. Then we can use either consume as flow or consume each to collect the send values. And we can use either send or offer function to send a value. However, a conflated broadcast channel is not suitable for state management because it can be either closed or canceled. And also it is too complex to achieve something as simple as state management. Um, Therefore, we need a better solution, and this is where StateFlow comes in. So StateFlow was firstly introduced in Coroutines version 136 as a new primitive for state handling. Uh, as it is a subclass of flow, it is very important to always remember that StateFlow is actually a flow, and it represents a single read-only state. This means StateFlow inherits flow operators, for example, map, filter, zip, collect, fold, and the other. And it has a single updatable data value that emits values. That emits updates to its collectors. This sounds very similar to LiveData, considering the fact that it also has immutable version of itself. And this code shows a sample of StateFlow implementation. The field consists of two parts, uh, a private mutable state with initial value and a public immutable version of it. As it is just the same as flow, data collection is done using .collect inside a coroutine scope. And in this example, we are going to print any emitted value. So the main function starts by observing the state, and then we try to update the data twice. And as for the output, it prints the value in exactly the same order it was assigned. One of the most important concepts is the fact that state flow never completes normally. We can cancel downstream data collection, but we cannot cancel the upstream data emission. This is also one of the biggest difference it has compared to conflated broadcast channel. And yes, StateFlow is designed to completely replace conflated broadcast channel in the future. So this is how StateFlow works, very similar to live data. And because of this similarity, some people begin to argue that StateFlow exists to eventually replace live data. Is that true? Well, to have a better understanding of this matter, let's see the differences between StateFlow and live data. The first and the most visible difference for StateFlow is we cannot leave the mutable constructor empty. If we don't assign any value to it, we will get an error telling that no value passed for parameter value. While for live data, it is possible to leave the constructor empty, and it is also possible to assign initial value to the constructor. The second difference is also quite a simple one. StateFlow needs either a coroutine scope or a suspend function to collect data changes, while live data does not. It only needs a lifecycle owner and an observer to observe data changes. The next difference is the most interesting one. StateFlow always replaces one most recent value to the new subscribers. For example, we assign A as the initial value, then collect the changes, then assign B, then C as the next values. The output prints ABC, while in live data, the subscription behavior depends on which method we use to observe data changes. If we use .observe, then we will lose the initial state because the observer will only receive events if the lifecycle owner is in started or resume state. As the result, we will only get B and C as the output. And last one is the most cruel difference. StateFlow has many operators, while live data has only three kinds of transformations. Based on these differences, you might want to consider adopting StateFlow to your architecture. But the question is, how about the migration cost? Is it going to take a lot of effort? Actually, adopting StateFlow is quite simple, considering the fact that it is very similar to live data. So the next one that I will explain is not only how to adopt StateFlow, but can also be a simple migration guide in case you have decided to use StateFlow. Let's say we have a main view model class, which uses healed as dependency injection, and this class has one use case, get droidCon events, which returns a list of string. And then we have a private mutable live data with state.initial assigned as the initial value. And there is also visible or public state and a download event method. If we want to migrate to StateFlow, all we need to do is to change this one to this. So it's actually a very simple process. Um, and I don't think this require a lot of effort. Okay, that's for the view model part, but how about the view part? Okay, let's say we have an activity. It has the main view model I showed you earlier, and it observes state changes at onCreate. Then call viewModel.download events. It also has a render function to render the view based on observed changes of the view state. Um, to migrate live data implementation to StateFlow, all we need to do is to change this part to this. This is also a very simple process where we only need to change observe to collect, then use lifecycle scope.launch. As for why lifecycle scope.launch, that's because when we are working with StateFlow, we need to consider stop the data collection when, let's say, the lifecycle owner is already destroyed. So the best possible solution is to use lifecycle scope.launch, and that's it for adopting StateFlow to app architecture. And now, how about the testing part? Is it difficult to test StateFlow? Well, testing stateflow implementation is surprisingly very simple. Uh, Firstly, we need to make sure that we use test coroutine scope. And then let's say we have this unit test. The first thing to do is to define the expected outputs. Uh, and after that, we have emitted values, which is mutable list of state. And these emitted values is actually to keep track or to keep the data changes. So whenever we collect the data changes, we can put it at emitted values, and then when the download event is called, we can later assert if the emitted value is equal to the expected values. And I think it's very simple, and the testing process is also very simple. And overall, adopting StateFlow is also involves a very simple process. And whether if we want to choose between StateFlow and live data, uh, we might want to consider the number of operators and also the subscription behavior, and also whether or not we want to use a coroutine scope in our view. I think that's the end of my presentation. If you have any question, feel free to contact me by email or add my LinkedIn so I can provide further explanation regarding this topic. Okay, is there any question? Okay, the first question is it worth to use uh, as live data conversion on views and use StateFlow on repository or view model to fully use the operators? Okay, actually, I see there is no reason to use as live data because we can actually collect data with StateFlow, and actually, if the data collection can be done with StateFlow, and why should we use as live data and then we use observer? Um, maybe there's a consideration like we prefer to still use the live data, but I don't see any strong argument or strong reason for that. So is it worth? I don't think so. Okay, that's for the first question. Uh, the next question is: do you think that Flow is going to substitute live data? Well, actually, there have been many arguments about this. Many people starting to say that uh, StateFlow is superior to live data, the way it has more operators, and it also yeah, it's also easier to use. But to me, actually, there is no, uh, let's say, valid source, or there is no also strong arguments considering the difference between the subscription behavior, like what I told you earlier, that whenever we use live data and we use observe function, uh, there is a behavior that the initial state might not be emitted, while when we are use StateFlow, we'll still have the initial state collected. Um, so I think StateFlow, we cannot say that StateFlow is going to substitute the live data. It's too early for that. Okay, thank you for the question. And the next, StateFlow is a cold channel. Um, Actually, StateFlow is not a cold channel; it's hot channel. But actually, it's not a channel. Actually, it's a flow. So there has been several changes of the definition of StateFlow these days. The first, it was introduced in Coroutines 136 as the direct subclass of flow, but and then at Coroutines 1.4, the definition changes from the direct subclass of flow into a direct subclass of shared flow. So they introduced man in the middle. It's the shared flow, and the shared flow is the subclass of the flow. So actually, um, to tell that is it a hot channel? I don't think so. I don't think it's a channel, and I don't think it's that hot actually. Okay. The next question is: there is a latency when observer dot observer. Sorry. The question. Oh, the question gone missing. Okay. So I'll just take to the uh, top question. Has Google made any question? Has Google made any statement about StateFlow over live data? I don't see any statement yet so far, and I think it's still a matter of preference, a matter of which case we get, or maybe also, yeah, the case like, for example, we want to we're already using live data, we're already using FVVM, maybe we still want to stick with live data. But for example, we're working in a new project, and then we still have no idea what to do, and the operation is quite complex, where, for example, we need zip function. Obviously we want to use StateFlow. Okay, the next question is, there is a latency when observer.observe is called after posting a value on live data. Is there a similar latency for StateFlow too? Um, Latency, yes. As it is asynchronous, asynchronous means there will be a latency, but it won't be big, it won't be large, especially if we don't introduce a huge delay, and especially if we don't use it, for example, like make a HTTP request. There should be only a small latency. But yeah, it has a latency. Thank you for the question. The next is, live data actually has a case when subscribed again to it. Does StateFlow have an operator for that behavior? Oh, okay. Yes, live data has a case. So when we subscribe to it again, we'll get those changes, especially when we use observe forever. Yes, we will get it. But in StateFlow, I think such behavior doesn't exist. So we whenever we collect the value, or whenever the new subscriber come, uh, it only emits the latest updated value. But yeah, maybe that's the case that you said earlier. But the case is only the latest updated value is cased, but the whole history is dropped. Okay, thank you for the question. And the next is, reinforcing the question, because he emits without anyone listening, is he cold? Okay. Basically, yes, it is cold. Like I said earlier, it's not hot, because it emits without anyone listening. So even if there is no collectors, we can still update the value. We can treat it like a normal primitive, like the definition of the StateFlow itself. It's a new primitive, and obviously, yes, it is called. Okay, thank you for the question. And the next is it worth enough to move to StateFlow? Okay, again, this depends on the case. Um, if let's say the case is, we have been using something like FVVM, and everything is already working, and we're working on a big project, and like everything has already stable. Maybe we don't want to convert the old codes or the existing code into StateFlow, but maybe if we are working on new codes, maybe we want to consider moving to StateFlow, because StateFlow has a various of really helpful operators, which can make our job really easy, and make everything easier. And oh yeah, but if we are using something like MVP architecture, definitely it's worth it, because like if we want to adopt StateFlow in MVP, for example, we want to put it inside our presenter, it makes our presenter not clean anymore because uh, the definition of presenter itself, why we introduce a clear difference between presenter and the view, it's because the presenter should never keep the view state. uh, that's why when we are working with MVP and we want to adopt StateFlow, it's definitely worth it. It also simplifies the code a lot, and yeah, it's definitely worth it. Okay, and the next question: does StateFlow need to be closed when it is no longer used? Okay, this is also a very good question and very important question also, because StateFlow has a nature where it never completes normally, and once we collect it and we forgot to cancel the collection, the value collection might continues, and it keeps collecting values that the StateFlow emits, and we might end up having an unwanted behavior. So does it need to be closed when it is no longer used? Yes, it needs to be closed, and one of the most convenient way to achieve this is by using lifecycle scope that I show you earlier, because whenever we are using lifecycle scope, it is following the lifecycle scope. So when it's destroyed, it's also canceled. Thank you for the question, and I don't see any more question. Okay, okay, we have another question. State flow have a limit? Actually, if it is a limit of how many times it can emit values, then no, it has no limit. We can emit as many values as possible, and not only emit as many values as possible, we can also collect as many values as possible as long as the collectors is not cancelled. And if you're saying about the limit of, for example, time complexity, then yes, Stateflow does have a n time complexity where n is the number of the collectors or the active subscriber. Okay, thank you for the question. Is there any more question? Okay, I think that's it for uh, today's session, and thank you for attending. And if you still have more questions, please contact me through email or at my LinkedIn. We can have a chat. I can further explain things to you, and I can make things clearer. And I guess that's all for me for today. Thank you very much for attending.